So hi there, everybody. Now we're going to apply what you just learned about the schemas in writing a parser plugin. So as mentioned before, we have this nice companion guide called the documentations that you can always consult by the side. I'll just be going in this presentation over the same structure, just from a bird's eye view, touching on a couple of points that I think are interesting for pointing out, for taking up, but you can always go through it in your own time. It's much more fleshed out there, and there might be some additions coming there in the recent future. Also, this talk is being recorded, so don't feel the need to write any notes down. Just follow along. If you have any questions, you can also interrupt me while I'm talking. We can make this very interactive. I actually like those kinds of interactions much more. So getting started. Essentially, when I go to conferences externally and present myself as Nomad, one of the first things that people typically remember from Nomad are all of our parser features, right? We contain over 60 parsers, and the main objective of these parsers is that Nomad acts as a research data management tool. And what we're really trying to do is remove all the friction from this aspect, so you can focus on the actual science, right? And this means automating the process of extracting the information as much as possible, because the other option is that we kind of provide more or less standard forms that you can then fill out. This is going more in the electronic lab notebook direction. So parsing as a process more or less exists out of 5 steps that we can recognize. I don't know if you can see my cursor as well. I'm just going to assume that you can, else I switch over to the laser pointer. But essentially the first step, and this is going more or less in the same order that the program would run through it, is that you provide it with some kind of upload folder, and it will be scanned through file by file to select the files of interest. Then these files are extracted and made workable. Then we kind of do this mapping. We identify the relevant pieces of data fields that we want to map into the new schema, this kind of standardized schema. There will be some data mangling there, so that there might be some conversions that you have to apply. And then finally, we construct this new schema that has much more functionality added to it. Now, if you were to ask me, what are then the responsibilities of anybody working on parsers? I'd say that, as with any repository, and this is now the nice thing, is that these parsers, as being plugins, can be maintained as standalone repositories. It means that you do the typical upkeep of a GitHub repository. And then there's, of course, this coding and annotation aspects that I'll be touching on in this presentation. But I'd say that really the core essence, and this is something that ironically I can't really teach you, is the domain expertise behind it. I'll get a bit more in depth by this to this point by the end. But when you're doing this mapping, you're essentially providing an interpretation of the file format as you're standardizing it and making it available to other people in the community who will take you on your word for that, right? So there's a lot of scientific insight that goes hidden behind that. And I really think that this is the most valuable feedback that we can get from the community regarding parsers, of course. So throughout this presentation, if later on you want to go and check out the code snippets, they're all together on this nice branch. You can also find it via this documentation in the companion guide. And if you just want to play a bit around with it and keep it stored, then you can just fork from this branch under this repo. But let's say, hypothetically, that after this you feel very encouraged to start working on your own plugin, be it a parser or something else. You can go and look up our Nomad plugin template. Again, link is in the documentation. And you should locate this green little button and click on Create a New Repository. The step-by-step instructions are down there in the README, but really it's a very simple process. Only 2 minutes of your time are required. essentially what you'll do is you'll say where you want to deploy this new repository, then you will pull it locally, and from there you will dynamically generate a template. That means that depending on what specific use case you have in mind, the exact structure of this template may vary. You saw a similar figure before in the previous presentation. So this is the layout of the folder structure for a plugin parser. So in the top level, you have, I think, what are mostly clearly annotated folders and files. The PyProject TOML is a setup file that regulates all of the dependencies within the module. And then under source, you will find the actual code. What is really relevant is that for the parser, you have two folders present, both the parsers, obviously, but also the schema packages. And you'll see later on why. Well, you can kind of intuit from the previous presentation already that if you want to extend locally just for a specific use case scenario, your schema, you can do that here. And we can always afterwards see together if this can be extended or incorporated within the main schema package. So here on the right-hand side, you see some annotations that refer to this entry point system. So entry points is a standard Python functionality for how to publish modules provided by the setup tools. There is a link to the entire explanation of how the system works, but briefly said, there are multiple components. The entry, most importantly, are the target functionality. This is what you actually want to expose outwards. And then there's the entry point, which is a kind of registration system by which you do this. You'll see more about that in a moment. These are then mentioned in the setup files, where it will list it under the specifications. It will essentially tell you which entry points are being incorporated within the module that you're presenting and how they are incorporated. And normally, when you have such a dependency, you can just pip install it. Actually, a very interesting quirk here is that if you pip install it, even in a local environment such as Chema showed before, it will still become globally visible. So it can be globally picked up, meaning that you can structure your Python setups however you want. You can either aggregate them all together or keep them separate for the Nomad base and for the rest of your plugins, however you prefer. Typically, Nomad will pick up automatically on these. If it doesn't, you can go into the Nomad YAML. This is on the Nomad-based side, and you can then further tweak the configurations or set specific parameters of how you want this to work. Right? And these all refer back then eventually to the target functionality. So with that, we're going to go a bit over these steps that I mentioned before. So the first one is file selection. And the file selection is done via this entry points system. So down here, you can see the exact code snippet, so feel free to scan over it. Essentially, there are two kinds of files that we distinguish within upload. So one are the main files, and then there are the auxiliary files. The main files, typically the standard output of a code, is essentially any kind of file that allows me to recognize which parser to use, right? This means that typically this will be the files that are also processed, but they don't have to be necessarily. And there might be additional files that you want to pick up on. Just give an example, we'll work here throughout with VASP, with the VASP code. I think this is widely known within the Ab Initio community, but you can extend this to any other code. Essentially, you can just essentially a main file would be something like the VASP from XML or the outcar, whereas the auxiliary file would be something like the DOSCAR, where you have the density of states written out. So these more spectral items that are separated out. So there are several ways that you can target, or that you can describe which main files to target. You can either work via extensions. There is an alternative way of providing a file format called a MIME. It's also very standard. You can just go by some kind of naming convention if there are these hard-coded names within your community, or Nomad also gives you the option that you just read a little bit of each file header and decide, depending on that contents, if you're dealing with the right, with which code you're dealing. So actually, this registration gives some
general descriptions of the parser, how you want people to essentially find it. What is really most important are these registration fields that target the specific main files. You can find, again, all of these keys in the documentation. And then there's also this little part that the entry points provide you with the load functionality. That's how they work. So you have to kind of personalize that, but really you can just follow the template in this case. So now that we have our plugin ready to go, let's try and hook it up to the Nomad base. So the Nomad base essentially provides an interface. This is to say, when you want to use it as a parser, you are implicitly accepting a kind of software contract that you have some rules that you have to abide by. This is very similar to any kind of API over the web that you're used to dealing with, right? Now, you can go and read these exact explanations or the exact rules, but we provide a nice functionality that already covers all of them called matching parser. Because, and essentially, the main aspects that it covers are the main file to be passed. So what will happen is Nomad will identify within a folder all the kinds of main files that you have, and then it will pass them one by one through. Then there is also the archive, which is a kind of intermediate data object that will eventually be written to disk. And this is what is actually stored on the database side. There is this logger, of which you already saw an example with the bound logger, that just keeps track of messaging and how the process went. Very useful for debugging. If I have some time at the end, I might touch on it. And then in case you have some more complex structure whereby you want entries, different archives to refer to each other, you can also supply child archives. This is especially interesting when building out workflows, but I think that for our use cases here, this is kind of going outside of the scope. Another important thing is that you should not, via the parse functionality implemented by matching parser, return the archive. Rather, it is simply overwritten directly. The reason for this is that you can constructively build it up and don't have to duplicate the data twice before returning it. Of course, you can return something, it wouldn't really create an error, but nothing is going to happen with that. And with all of that knowledge, essentially what we can do is we can just take this matching parser, inherit all of the stipulations that it gives, and this will be the most bare bones parser that we can generate. Up here, I'm just mentioning where you could find in the example repo this code snippet. And that's it. We've just created a parser. It's that easy, very low barrier to entry. So then how do we interact with this parser? Well, there are a couple of options. You already saw in the beginning that Nomad offers both a GUI, a graphical user interface, but also an API by which you can connect with it. It will automatically then recognize and call the relevant parser. So you don't have to do anything else there. Just go down the other tutorials if you want to learn more about how these entry points work. You can also call it from the command line. Personally, as a developer, I find this very, very useful. This is the main way that I debug them. You can specify, if it's not picking up the parser that you like, which one you wanted to use. But really, the most important thing is that you specify the main file. You should also really give it the show archive, so you get the archive returned, and you can essentially store it to disk and investigate it later on. In some cases, it might be nice to just deploy your own Jupyter Notebook and do the parsing on the fly, just to try out a little bit with some initial file formats, not for the big kind of data analysis. For that, we provide a template in the documentation. But the most important point here is that both of these previous cases were covered by the Nomad base, but now the onus is on you. So you have to provide it with a main file. That should not be too hard, it's just a file path, but also with an archive object and with a proper logger object. You can just keep these child archives void. And if we then actually run it with any of these kinds of implementations, we will get back an error. So that's great. What's going on? Well, the thing is fine. This matching parser provides you an interface. but it understands that nothing really of value is being produced, right? We're not really doing any processing. So what it's telling you is that you should actually implement this, this parse functionality. That is to say, we're going to specialize it via inheritance. That brings us to step 2, extracting the source. So we have access now to our main file or the auxiliary file of interest. We're going to try and extract some data from there. We'll be focusing on the XML output of FASP, but again, this is just one specific example. You can extend this freely. So then, regarding the choice of a reader, this part interfaces with our parser. It does not directly interface with Nomad, meaning that you're completely free in choosing which reader you want. There are many common file formats such as JSON, HTML5, and also XML that allow you you have a whole litany of readers already online available. You just choose whatever you feel most comfortable with. In some particular cases, Nomad also offers readers that are typically extensions of this. This is also what is happening here with this XML parser, which is an extension of the element tree. Some other points to note in this setup. So this is essentially the parse functionality with this interface that is specified in the previous slide. We have a reader that takes, in this case, the main file to process. And then we write down its outcome, its results, to archive.data. So the archive, I wouldn't really call it an interface because we're dealing here with a schema structure, but it has some kind of like top-level structure that comes with its own semantics, its own meaning, and you should really respect that meaning. The ones here denoted in blue, they are mostly on Nomad side, so the meta info is somewhat of an internal bookkeeping of when was the parsing done, who did it, and other aspects for storage. So this is really just internal for Nomad. Then you have these results, which are the data that we will make searchable, that we will index, and then you can query for them. Again, this is an internal aspect. These are automatically generated by Nomad. What I would suggest you to focus on more are the workflow and the data. So the data is the one that we have now built out this Nomad simulation schema for, the one where already experiments are being populated. There is an older version for the for what we call the legacy schema, and this is also what currently most of the parsers still write to. We are in the process of migrating them, which is called run. So it might be good if you check out an archive to check under run, especially if it has not yet been reprocessed, but this will be phased out over time. And definitely new parsers should not target it. For the more complex interactions between various archives, you can populate the workflow section, but I'm not going to talk about it here. Then we can run this again, and we'll end up with, well, not anymore a not implemented error, but we get a different error. That means that at least we've made one step of progress. It might not be as much as we would like to, but I assure you that soon we will be out of the errors. So what is happening here? You've actually seen this error message before as well. What is happening is that Nomad is complaining that you're just passing data that is not compliant with the rigid standards of the schema, right? So we have this very high quality schema that enforces these standards. You've seen them in the previous talk, and we should respect them. We should really follow those. So let's take the data and convert it in a way that we can work with that. That is kind of also maybe step 4, but mostly what I would call step 5. So the way to think about parsing is that it's a process of mapping between two trees. You have your source of your original file format, and then you have the Nomad schema, which can also be thought of as a tree. So tree structure in this case will follow this kind of example. Looks like a starting root that then branches out into several nodes. And when a node hits the end of a branch, it's called a leaf. Note that here we have these sections, and then we finally have the quantities annotated under them. So there are two ways that we can go about it. The first one, and this is really the safest way, this is what you can always fall back to, is that these are classes, so we can just go and instantiate them one by one. Then we get objects that we can populate with the actual data, and that we will write to the archive. So here is a short example of how that will look like. Again, notice that we're working in this parse functionality, and there are just a couple of things that I would like to point out. So first of all, you can very clearly follow the tree structure or see the tree structure reflected in this way of annotating. So this is essentially, you can follow along simulation, down the program, and up, down all of the, all of the leaves. This is because we've used a more declarative approach where we keep the entire structure together. This is done by doing the instantiation and the filling at once, all together. Now, there is a little thing that is, it's something that I think is worthwhile pointing out, but gets a little bit technical, especially for people who are used to working with Python. It is something that might seem weird at the first moment. So what happens is that we are kind of used to working with instantiation in typical Python, that we give it attributes, right? But typically these are then listed in the initializer of a specific class. However, if you go back to any of the schema section, what is happening is that we are not writing anything to the initializer. We are just populating it with class attributes. So what is going on here is that in practice, Nomad uses a kind of, like, you could call it a dialect of Python. It has slightly modified the way that the standard Python behaves to specialize it into this parsing and to the schema construction, so that these class attributes can really be handled as if they are specified within the instantiator. So it gives this very nice segue, this very nice bridge between the two ways of writing. I think for people coming new to Python, it feels very intuitive, and even for those a bit more accustomed to it, you might the first time say what is going on, but then once you see the trick, I think it's very nice because it kind of mocks the way that you would typically work with them. Enough on that point. If we then run this actual parser, you will get some kind of archive.json that again preserves this tree structure. You can nicely go over them and go over all of the branches. Note that now we're not referring to the actual sections, but the tags under which they existed, right? That would be these tags here. And the root one has a special, is annotated slightly differently with this mdef annotation. So now I'll cover this part very quickly, because these are more like technicalities, but I just want to show that we are building out this protocol. Actually, that documentation is like the first version of it, that kind of gives you suggestions on how to approach certain problems, essentially mitigating all of the technical difficulties that you would typically encounter. So really, we're trying to lower the barrier to entry there as much as possible, so you can focus on this mapping part. So this declarative style is very nice. It maps directly to the tree, but it might not always be possible. There are some scenarios why you might have to abandon it, such as, let's say, you're not guaranteed that a certain section will be present. This is less important when you have leaf nodes, but when you have higher up nodes where entire branches depend on them, you should maybe start adding some kind of construction logic. Here you have an example. This is with essentially when a geometry optimization or a molecular dynamics runs in VASP, it will print out multiple positions, multiple updates, and at the end it will say, well, I have this final position. This is like the final end result. Suppose that you're targeting this. What may end happening is that suppose that it got interrupted, or the final writing was corrupted. You might not be able to retrieve this. And really, there should be some kind of logic to handle that, right? The most important point for us to note is that now you really have two different blocks. So you have this if statement. You could further extend it to also have if-else, or kind of like backups, but they are living completely outside of this simulation, out of this archive data tree. If you start doing this too much, it will kind of break up or disperse this tree structure, and it will be much harder to visually map the two concepts together. And really, clarity is something to strive towards. In other cases, you can actually try and retain this tree structure. So suppose that there are multiple fields that you have to check that all, so different fields in the output format that all map into the same nomad schema field or attribute. And a real pragmatic example would be that VASP has different keywords for different runs of Jacob's ladder. These are different versions of the FT that require different routines. Originally, it had GGA, but in some kind, and then special LDA tag, and later on, a meta GGA tag was added to it. So what you have to do then is, in this case, we can leverage a nice little trick, is that Nomad allows you to readily convert its own internal, very actionable file format to a Python dictionary, which has this nice little function called get that allows you to capture something by key name, but it also allows you to essentially have a fallback, like a kind of default. And if you just fall back on dictionaries, you can keep on chaining several possibilities together up until the final default, which in this case would be PBE. And again, the very relevant part to note here is that we managed to retain this tree structure as a whole. Then there is this other option that I mentioned. In plenty of cases, a lot of this mapping or a lot of this construction part can be done automatically. I'm going to show you some code, but this comes with a very big disclaimer. This is still a feature under development, a very, very recent feature. I think it's interesting to show the concepts. Those are more or less in place. But the exact code snippets that I'm going to show you might completely change. So don't pin me down on that. This is different from the other code snippets that you saw before, which do allow you, which you could actually keep on utilizing, right? And you can always fall back to the previous one, but I think this system is a little bit nicer, a little bit cleaner. So we have control over two schemas, the incoming output schema and the nomad schema. Since we have most control over the latter, it's probably nicest to add the annotations there. And this will result in a very short parser. And again, like I mentioned, you can fall back on the manual option. That's it. That's the entire parser, barring maybe some login logic, but that's not too relevant. It's just 3 lines. You just essentially load in our annotated schema. They'll show in a second. Then you process the main file and convert it using, so convert the data from here to that of the annotated schema. So this further enhanced schema, and then we write it again on the archive data. You already know this part. Just note that what is called here XML parser comes from a different file. This is an updated version, so these are not the same as what you were seeing before. So this is in the parsers part, but as I mentioned, we also have this schema packages folder, and that is where you can add one big annotation folder, right? So there are really 2 reasons why you would create any kind of Python script under this folder. One would be that you want to extend our regular schema, and the other one is to annotate. I wouldn't mix the two, but I would, because it also makes it harder if you later on want to move this into the main nomad simulation. Really, you should keep kind of like the extensions or the semantic extensions of this schema separate from the annotations for the mapping. And this is how they look like. They just go line by line. And you can specify multiple kinds of keys. This is very nice. For example, in the case of VASP, you have next to XML also an HTML5 output and also a text output. And you could actually map all of these under each other so you can compare outputs. Don't quote me on this, but given that the fast HF5 output is a little bit more modern, a little bit more recent, it might not have all of the exact outputs that you're used to in the XML. So this allows also for a very nice comparison between file formats. It rolls out very naturally. We're really close to the end now. I'm just going to tie up a couple of threads that I opened up. So one thing is that I mentioned this text output or this text format, right? So the problem with plain text is that it's very easy to convert it to a string data, but it doesn't make it, first of all, actionable enough, and second of all, it doesn't provide this tree structure to it, right? So this is an additional responsibility for the parser developer when handling text files. I'm very sorry, but this is why these are somewhat of the older file formats, right? So we'll convert this back to a tree. We'll use also keys, so we can very easily retrieve the node that we want. This is done using regular expressions, where it's very important that you incorporate specifically by which part you recognize the text and which part of that you want extracted. And the typical tactic to build then a full tree out with this is to use something what I personally call weaving. And here's an example of that. So what happens is there are two players involved. There is this text parser, by which you will start, that is your root. And it lists several quantities. These quantities do the actual regular expression matching and extraction, right? However, a quantity can call something like a subparser, which is typically, again, a text parser, and then you have kind of interwoven the text parser with the quantity, right? And you've opened up a new branch that you can further explore. So that's the tactic there. And really, the key part here is that, yes, on the one hand, now you have extra work to do because you have to do this conversion. But it also means that now we are introducing three kinds of formats. You have the original format, the nomad schema format, and you have this intermediary format. And you can use this very strategically to your advantage to really minimize all the rest of the complexity of mapping into the nomad schema. So here are just some suggestions there. So one thing is try and follow as much the same structure of the original file. This might not always be possible because some sections might incorporate others, but as much as possible, just so somebody can really have a file open next to your code and kind of like scroll to them in parallel. Try and retain the original naming. Sometimes certain sections or parts of text are not really given any name. In that case, I would say take over the nomad name from the nomad schema, but as much as possible, please avoid your own naming, because this means that you have just more complexity to keep track of. Then whenever you're presented with a block, especially like tables, and there's a special explanation about it in the documents, try and use this weaving tactic that I explained to really break them down into nice little trees that you can traverse. And sometimes it might be that there are multiple options again that you encounter, a bit similar to this example above with the string of gets. In that case, you can just use the same key to which you're mapping, and the text parser will take care of the rest, as long as both options cannot be mutually present at once, as long as they're kind of like exclusively present, right? But to be honest, I mentioned that we're creating these protocols, so some of those are really like very strong recommendations. This I would call more something like a guideline than actual rules. So take it for what you want. Kind of try and see if you can find your own shortcuts within that. And with that, we've come to the end. So I've traversed through this entire section on similar to what we had in the documents, just referring in the end back to this section, self-referentiality. And we've covered a couple of these parsing execution steps. But there's still these two open, step 3 and step 4. So regarding data mangling, I can be very brief. You've already seen how to normalize in the previous presentation. please use this whenever you're confronted with a very complex case. This is again why we have this schema packages folder. You shouldn't put that into the parser. The parser should at best handle almost trivial kinds of conversions, right? Something that you would typically write as a lambda function, for those of you who are familiar with that concept, or maybe a static method. A static method means this is a method that is hosted under a class, but it doesn't use any of the information of the class itself. So no self, no class to take out. Really something very simple. The most important point, and this is not a guideline, or this is a very, very strong recommendation, is it shouldn't go into the construction logic. As we saw with this if statement that had the two different blocks, it should leave that structure intact, right? This is just tying up two extractions together, doing some kind of conversion to the right type, adding some units, that's all. Not anything more complex, we go back to the schema. And this also means that then other people in the future will be able to use your normalization, and they'll be grateful for that. So with that, we can also mark off part number 4. And just some slight final thoughts on this step 3. This is the last of my slides. So in summary, what is the most important point with parsing? I've kind of gone over the coding setup and the technicalities. However, I would say most of this we try and provide with the tools, the protocols, as you've seen, in actually building out an entire ecosystem and connecting people to each other. Also, the Discord is part of that, where you can ask us questions. Really, what we're trying to do is lower the barrier to entry there as much as possible. Like, this should not be your main burden when writing a parser. Instead, and this is something that I cannot teach you because you actually already know it, is this step 3 about the mapping. Right, you're doing some kind of interpretation of this file format, and this is a very distinctly human element. Until maybe LLMs replace us all, but up until then, let's say it is a very distinct human element. I'll just give you 2 examples so it becomes a little bit more concrete. So imagine that you're dealing with this fast XML, and these are really questions that we have to deal with on a daily basis. Is okay, you find multiple energy outputs. What do these fields mean? Which one is my total energy? Which is the one that I should showcase? Now, for those of you who are curious, this one has some temperature effects in there that are added for numerical reasons. And for metals, you should refer to this one, right? So this is already a very complex kind of distinction because you have to know what kind of material or material class, rather, you are working with, right? But these are the kinds of distinctions that we need, these kinds of insights. And then also on the schema side, again, there are all kinds of different domains and different use cases that might by times require more specification or more level of detail, right? Even something as simple as a scalar, just like a band gap. For some people, this is sufficient. This is all they want. But in some cases, this scalar actually has a spatial dependence, so then we have to distinguish between direct and indirect. Where's my cursor? I can't see it anymore. Or you might have some kind of intermediate levels that come from impurities. So especially in solar cell applications is very interesting. Then you have to distinguish, again, different kinds of band gaps. So these are the kinds of contributions that we need, because by the end of the day, if we take the Nomad schema and we remove the community consensus that is behind it, all the people that were daily in contact with talking, and you remove this aim for both generality of semantics, of read the meaning, but also the clarity and the specification when needed, and you remove all these kinds of applications that can work with them, then in the end, it ends up being nothing more than just another tree format as we started out with. So all the added value comes from this interaction. And this is where, oh, my cursor is back. And this is where you, as a scientist, as a domain expert, can really give us feedback. And I'm sure you have it. It's typically even in things that you would consider so trivial. Only once you start talking to people somewhat outside of your domain will you notice that there are certain notions of concepts that do not line up. And this is what all the people who are presenting here today as area experts do, we do that on a daily basis, but we're only 4 people, right? Definitely, we want to have community consensus and feedback. That would be my main takeaway message of parsing. Please try and focus on that. I'll let you ruminate with that